years, cloud seeding is the oldest and simplest weather modification technology. All clouds are made up of some form of water vapor. For raindrops or snow to form, a tiny impurity called a condensation nucleus must be present, but in nature they're rare. Cloud seeders use airplanes to inject impurities into the clouds. The water vapor forms droplets around these nuclei, eventually growing 100 times bigger, big enough for gravity to pull them from the sky. In a standard seeding scenario, the cloud bottom plane flies below the base of the cloud and releases silver iodide particles into the warm, rising updraft. The cloud top plane pierces the cloud core and drops dry ice directly into the supercooled vapor region at high altitude. This is Tad Delsing. He'll be one of the pilots flying out for today's seeding run. It's his job to prepare the plane for what might be a rough ride today. Along with typical fueling and flight check tasks, Delsing also needs to fill the silver iodide seeding tanks. Then he'll wait for Geiger's call. Cloud seeding pilots are not typical fair-weather flyers. They spend every day penetrating weather normal pilots avoid.
Unfortunately, doing this type of job, you're going to have some encounters, no matter how careful you are.
Pilot Kyle Spencer will be flying the cloud top plane today. He's had his share of frightening experiences.
Been struck by lightning numerous times. Most of the time, the lightning will just hit like the wingtip of the aircraft.
The Cloud Warrior's worst nightmare? Getting too close to the enemy.
My very first season, a hailstone came right through the windshield of my airplane and just grazed me on the neck and ended up in the back seat, still about a baseball-sized hailstone laying in the back seat of the airplane.
Back in his office, Geiger's making his final decisions about today's seeding flights.
Anything that deals with weather, forecasting, or just the general environment out there, you do have to have a little bit of luck and art and some science, of course. It's more observation, getting an idea, your gut feeling for what that storm may do later on as it continues to mature and grow.
Geiger is surveying his target area for a specific type of cloud, one that's large enough to contain a supercooled region where water vapor is just waiting to freeze and grow into ice crystals, which later fall as rain. A front of large clouds are moving into the target area. Spencer and Delsing leap into action, weather warriors scrambling into battle.
All right, clear onto the runway.
As Kyle heads for the high-altitude cloud tops, Tad will cruise close to the ground and prepare.
All right, we are airborne. Wheels coming up. What we're going to do here is we're going to pull right up under these clouds here that you can kind of see are growing a little bit on the sides. And we'll actually be running just parallel with the rain shaft turning down here to the south, trying to find our best area of inflow.
Hawk 1 radar.
Yes, sir, go ahead.
Yes.
During his flight, Walt Geiger will continue to radio Tad with updates on the cloud's position and size.
Okay, I've been on it. It's just southwest and, or mostly southwest of you. And,
when Delsing finds the exact location of the updraft, he'll fly directly into it. As the ride gets bumpy, he'll ignite silver iodide generators to release the agent, where it'll be carried thousands of feet up into the cloud. Meanwhile, Kyle Spencer prepares for the more difficult task. He'll be penetrating the body of the cloud. At this ultra-cold altitude, dry ice is a much more efficient seeding agent, forcing water vapor to freeze around it. If they hit their marks, both agents will provide a massive infusion of condensation nuclei, and the raindrops will begin to build. But even after almost 30 years of cloud seeding service and some convincing results in hail suppression, there's still some question about cloud seeding's effectiveness as a whole. Scientists do generally accept that cloud seeding affects the clouds. They just can't measure or prove the results.
The problem you have in showing that it works in nature is that you can't do controlled experiments. So it's very difficult to say, you know, if a seeded cloud rains, that it wouldn't have rained otherwise.
Even without definitive proof, cloud seeding continues to be practiced in over 34 countries worldwide. But silver iodide and dry ice nuclei are Stone Age technologies compared to today's higher-tech particle payloads. The most amazing of these belong to a family of weather mod devices that are so small you might not see one, even if it was floating in your eye. Ranging from the ultra-tiny to the nearly invisible, these are the revolutionary micro-machines that will be the workhorses of any world weather control system. They're MEMS, micro-electromechanical sensors.
There are approximately 2,000 weather balloons launched globally, worldwide, every day.
Those balloons play a huge role in helping us predict and potentially control our weather. But what if we could launch 10,000 weather balloons a day, or 10 million? That's exactly the theory behind GEMS.
GEMS are global environmental MEMS sensors, a concept that we have come up with that deals with a massive wireless network of airborne probes.
The idea is to release 10,000 or more of these dust-sized probes every day from airplanes, stratospheric platforms, or satellites. Like weather balloons, the probes would monitor weather information over every kilometer of the Earth's surface at a resolution that is today unheard of.
We envisioned that the GEMS probe itself would have a bio-inspired design, something like a maple seed or a dandelion seed that actually incorporates the constructs of nature to achieve aerodynamics and buoyancy.
With an ongoing stream of millions of measurements, the accuracy of our picture of the atmosphere could improve 1,000 times over.
There's every reason to be optimistic that simply having more measurements of the atmosphere will lead to improved forecasts.
It's also possible that the GEMS themselves could be made to play an active role in cloud dynamics. In effect, cloud seeding with 1 million microscopic computers.
We could potentially use these very small devices either as cloud condensation nuclei to seed clouds the way that current weather modification is done, or potentially something even more futuristic would be to actually have the devices be active, where they could introduce some perturbation into parts of the atmosphere to actually modify the weather.
But if GEMS are heavier than air, what will happen when these millions of probes finally fall to Earth?
When the GEMS probes land on the surface, either in the water or on the land, they would continue potentially to provide surface observations.
But what about the ones that end up on your picnic table or in your hair?
At the sizes we're talking about, if you actually inhaled one or got one in your mouth or one in your eye, it would probably be no different than, say, a speck of dust or a particular particle in the atmosphere that you would get in. You'd probably sneeze it out or cough it up.
Useful as nanotechnology will be to weather observation and prediction, there's no question that it will also play a significant role in military weather operations. And it will simply be the newest weapon in a secret arsenal dating back more than 50 years. The history of the human hunger for weather control is as old as the species. And so is the relationship between weather and war. From Napoleon's defeat by the Russian winter to the Japanese use of a Pacific storm to cover the attack on Pearl Harbor, weather has virtually controlled the battlefield.
The military was always deeply concerned with the weather. Generals have been concerned about the weather since ancient times, and very rightly so. And so it was natural